All right, this is the AWS Sense Module 2, Safety and Health of Welders. So OSHA is the Occupational Safety and Health Administration. They were created back in 1970. The act was signed by Richard Nixon, and the administration was stood up in 1971. And of course, they are to ensure a safe and sanitary working condition for all employees. So it's a pretty good deal. You're safe, the government keeps you working, so they get a third of your paycheck, and everybody wins, right? I mean, you go home healthy, making your money, and of course, they get some income tax off of that. So part of OSHA requires that you have the right to know the types of hazardous materials that you're working in or around. So SDS's, safety data sheets, are required by an employer in order to inform an employee what they can be exposed to. So inside these, there's each product, for example, AL8 maybe has an SDS, and that is going to be 16 sections of anything that would happen or numbers you could call for who made AL8. Section 4 is first aid and CPR. If you eat it, swallow it, get it in your eye. I mean, obviously we're using AL8, so it's not a big deal, but a 7018 Lincoln Electric Excalibur rod, the SDS is 21 pages long. So again, 16 sections. I think section 3 is in case it caught on fire, you know, what would the fireman have to do? The 16 sections are nice because now you can roll in easy and find exactly the information you need. So firefighters know to go to section 3 when a product is on fire. It used to be they weren't organized like that. You know, Pepsi could have only 4 sections, Coke could have 26 sections, and all in different order. Now SDSs are uniform. Everything has 16 sections, and those 16 sections are all titled the same. So section 1 is product information, who made it, and how can I get a hold of the company. And again, that's all part of your right to know as an employee the types of materials that your company is exposing you to. PPE starts with eye protection. That is the number one piece. If you had nothing else on, you would need to protect your eyes. All right, so always worn in the welding shop, never taken off under a face shield or welding hood. Those protect your face. They are not to protect your eyes. So again, 2 separate pieces of PPE. Putting a face shield on does not mean you can take your safety glasses off. Clear safety glasses are great indoors. A lot of companies view the shaded lenses as hazardous inside. Obviously, it's already dark and with shadows inside the building. And then you put sunglasses on. That's not really helping you out any. Minimum oxy-fuel cutting and welding is a shade 4, and the glasses must be stamped with an ANSI code. All right, and we'll get into here. The next slide will teach you some more about ANSI codes. But Z87.1 is the lowest level. Z87 Plus is actually a high velocity impact rating, and then you can have extra suffixes. So this has an L8, a D3, and a D4. So this is showing the D4 is dust protection, D3 is droplet and splash protection, and L8 is a visible light filter, glare reduction. So these L8 would be like a mirror finish on them. So here's all the codes. So Z87 plain is just a regular basic impact. Z87 Plus indicates a high velocity impact. So take a little more brunt or blow. D3, splash and droplet. D5, fine dust. If you had a W on your glasses, they would be shaded for welding. Hopefully that would say W10, you know, and even then you'd probably get your face melted off or sunburnt. But you can have welding shaded glasses. UV protection, you'd have a U and then a number that would indicate the level of protection. And then you've got the R for infrared. Visible light filter, again, that's the L. We saw the L8 last time. There you go, L8. Prescription glasses, you can actually get, you know, your safety glasses done by, you know, an optometrist who gives a prescription and puts them right into your safety glasses. Those would have a -2 on the end of those. The head size, if you have an H, indicates they're small glasses made for kids, and a V for photochromic, or S for special lens tint. But if you ever wonder what all those suffixes mean, there you go. You can look them up if you need to. Face shields, worn for grinding, cutting, or other operations that cause flying debris. Typically, what you're seeing here, this is a shade 5 face shield because he's oxy-fuel cutting right there. He's got a hard hat on, and he's attached to a halo. Now you can get more, you know, Walmart style, but this is industry right here. So a hard hat with a halo, You can see maybe this guy right here too on the side. See that aluminum ring around his hard hat? He's got a clear face shield on maybe, and he's got evidently some shade 4 or shade 5 safety glasses on, but to protect his eyes because he too is oxy-fuel cutting. So that halo connects to the hard hat, and then your face shield connects to that halo. But eyeglasses are still worn underneath of that. And of course, face shields can be clear for grinding, and then shade 4 at a minimum for oxy-fuel cutting and on up depending on the operation you are performing. Welding hood, hopefully you're a shade 10 at least, and then that's going to go up as the amperage increases. So if I was arc gouging at 250 amps, then I might want to push to a shade 12. So that's determined by the amperage or the brightness of the arc, but typically that brightness happens because of the amperage, the current being flowed through. Again, eyeglasses still worn underneath the hood. Look at Brandon here. He's got his, just popped his hood up. He's got his eyeglasses still on. That's exactly how it should be. You're going to avoid flash burn, not by closing your eyes when you tack something, but by using your safety glasses and your welding helmet to protect exposure from that ultraviolet light from the arc. So don't be that guy who just closes their eyes or turns their head slightly and makes a couple tacks. Get your hood on. Even safety glasses, clear glasses, as you're walking by somebody welding, it's going to reduce the glare coming off that arc, reduce the chance of flash burn. What types of clothing can you wear while welding? Well, hopefully you're keeping all your skin covered, because again, it's going to give a sunburn. Even short circuit MIG welding for extended periods of time will give you a really good red tint to your skin. So cover all your skin up. Hopefully we're covered up with cotton or wool or leathers maybe. Synthetics are not good because they're going to melt to your skin. So if they, where cotton might burn, catch on fire, of course you can skin that off. The synthetics are going to burn and then melt, so you can't get them off. They're going to peel or stick to your skin. And watch your loose clothing. Get caught in some moving machinery. I've seen a guy get uppercutted by a grinder because the tails of his regular work shirt got caught in that, and that thing climbed his shirt quick and then popped him in the bottom of the chin. So watch your loose clothing. Jewelry can be pretty hazardous, pretty dangerous in the weld shop. Gloves. Leather gloves are typical. Thickness depends on the type of operation. So if I'm TIG welding, I need a feel, so I've got maybe some light duty gloves. If I'm arc welding, arc gouging, maybe oxy-fuel cutting, I might have some thicker leather gloves on. Those operations tend to be a little hotter, I guess, to my hands. So what types of burns are common? Again, we go back to maybe your TIG welding in t-shirts. You can get that sunburn. You can get a first-degree burn from just the radiation coming off of those processes. Let's say you pick up a piece of hot metal and your skin blisters. You get that burn. That's a second-degree burn. And then third degree, you'd probably have to a deep tissue burn. If you want to say maybe occasionally we get a third-degree burn, drop a piece of catch some slag down the shirt and just can't peel off fast enough, and that kind of sinks in there and gets one of those those really whitish burns, and that slag really sinks in there. That's a deep tissue burn. Typically third-degree burns can be upscaled depending on where they're at. So burns to the groin, neck, face, that kind of stuff tend to be usually get upgraded to third degree just because of the sensitivity of the area. But there you go. So first degree sun, second degree blistering, third degree deep tissue. So wear those gloves. Ear protection. At around 85 decibel, you're going to want to put earplugs in. Exposure to loud noises hurts your hearing, and your hearing never gets over that. It's not like getting a cut on your face and then it heals and it goes away. As your ears take damage, excessive noise, they never quite recover, and that compounds. That's why the older your grandfather wears a hearing aid. So use those earplugs. Here's this cat. See that blue cord going into his ear right there? That's to a set of earplugs right there. A lot of times, and of course he's grinding, so that's going to be 85 decibels. But even when we're just welding, welders like to wear earplugs to prevent sparks from going down their ear. I typically take that beanie bill and flip it over my left ear because that's the closest ear I've got to, I'm right-handed. But try to keep those sparks out of your ears as well. So welding hazards, you're going to want to know this. So the top 3: radiation, fumes, toxic gases. Radiation, of course, coming from that arc. We talked about getting sunburn. Fumes, just from welding itself. You don't want to get your face over top of the plume, over top of the smoke coming off of your weld. Hopefully you can back up a little bit and get out of the way. Let that smoke go up into your fume extractor, into the atmosphere, and you're not huffing and breathing that stuff in. Toxic gases come from welding certain metals. So you got a list here: zinc, cadmium, lead, chromium, beryllium, and stainless. Zinc is on galvanized, so that's going to give off a nasty fume, and then stainless gives off hexavalent chromium, which again is not a good thing to be breathing in. So here we've got some guys. These two on the right are actually they're self-rescue units for MSHA training. Actually, that's what they just got done doing. So that's if you were in a mine and there was no more oxygen left, and you had to pop one of these guys in to get to an exit. This is an SCBA, much like what the firefighters use, but it can be used for welding application as well if we're welding around some toxic gases. And typically that happens in a confined space. So a confined space is defined as a place large enough for a person to enter, but not intended for human occupancy. So your closet in your house technically is a confined space, right? I mean, when the carpenter built it, you know you can walk in it, but it wasn't designed for you to occupy, for you to hang out in. Never take compressed gases in with you. Oxygen monitoring is required to make sure that there's a suitable air in there to breathe, but you don't want to ventilate with oxygen. That would enrich the environment with oxygen and make everything highly flammable. Areas of less than 10,000 cubic feet or ceilings less than 16 feet require forced ventilation. So most welding shops are going to have a fume extractor to pull those, those particulates and those fumes out of your breathing area. And ventilation typically should be as close to the fume source as possible. Our hoods, we try to get you to weld directly underneath of the hood opening so that stuff goes right up and out, and again, you're not breathing that in. I think it's Keegan Dale's inside the hot box there. So there you go. He's in a confined space, all bowed up, TIG welding. So it looks like some 5G there on some 2-inch. All right, hot work permits. A hot work permit is basically you asking permission to perform hot work on a company's job site or on a host company's property. So it allows the performance of work potentially posing a fire hazard. So anytime you're throwing sparks, it could be grinding, depending on your company and how far they want to push it. But welding, cutting, all this stuff, we're throwing sparks, we could cause a fire. So you're going to have some information here, basic, name of the company, date, who you are, location of the, what's going on. And then over here's a checklist to keep you honest. Essentially, it's asking you questions like, have you prepared the area? Are there any combustibles within 35 feet? So you're checking yeses or nos for how you prepared the area. And then you're going to turn that into your boss, and he's going to look it over, and he's going to sign off and say, yes, you can go throw sparks. You can see the perforation here. This is going to be a carbon, so you got a yellow on top. It's got a white and a pink behind it. And you keep maybe the yellow copy with you, tied off to your oxy-fuel cart, and then that white copy goes to your company and the pink copy goes to the host company. But everybody has a record of your hot work permit that you've signed off on. Fire hazards, speaking of fire hazards, typically you're going to have a fire watch. All right, so if you're somewhere, there's going to be some cat paid to watch you weld in case a fire was to break out. So they'll have that hot work permit close, they'll have a fire extinguisher close, and hopefully they know how to use it. Your extinguisher types are A, ordinary, which is paper, cardboard, wood, ordinary combustibles. B, flammable liquids, so diesel and gas. C, electrical. D, soft metals. Examples are aluminum and magnesium. K is a kitchen fire. And how do we use an extinguisher? Typically, the extinguisher we're going to pull from the tool room, or our fire watch is going to have, is an A, B, C. So he's going to have all three of these right here. That's what all these are. You'll see a dry chem come out of those extinguishers. And these individuals right here are practicing the PASS acronym, the pull, aim, squeeze, and sweep method for using an extinguisher to put out a fire. We're going to pull the pin. It's got like a small, almost like a grenade pin, right, that keeps the actuator from initiating. So you take it off the wall, pull the pin. I'm going to give a test squeeze before I get close to the fire to make sure that I've got some dry chem in there. I'm going to aim at the base of the fire, not the flames, but the base, squeeze the actuator, and then sweep side to side to put that fire out. Cylinders, we always store those in the upright position. So these are, and technically you're not supposed to try to identify a cylinder by its color. I know these are Scott Gross brand. This silver or gray tank is an oxygen tank. That tall, slender maroon tank is an argon. But different companies paint them different colors. So you should never assume that. On the shoulder there, you can see the data tag. So I would want to read that data tag to be sure that I knew what was inside each cylinder. We can chain them up, we can number 9 tie wire them up, or a better fixed device for securing it in an upright position. So if you can barely see on that cart, there's a yellow bar that goes across both the acetylene and the oxygen, and it's got a screw in there. You tighten it with almost like a wing nut that screws down and secures those in the upright position. They're always capped when not in use, all right? So we never roll them around or move them uncapped. Of course, this is on a cart secured in the upright position. You might move this a little bit, but what I'm saying is you wouldn't take this bottle with the cap off and take it to the Scott Gross truck. You'd always want to cap on when you're moving them from point A to point B. There's that big metal strap that I was telling you about earlier, securing those in the upright position. Let's talk about the oxygen for a minute. Liquid O2 can cause frostbite, just like liquid anything, really. Think about the LP gas that maybe you use to cook with your grill. You go get propane at your local gas station or whatnot, and that comes out pretty cold. Those guys wear gloves when they're filling up your cylinders. Fully charged cylinder contains 225 at 90 degrees Fahrenheit. Cannot be used as ventilation source. All right, so you would not want to ventilate with pure oxygen. Of course, that's going to cause a very flammable work environment. Oxygen-rich environments are extremely flammable and essentially cause the flash point of everything to become way down. So things can catch on fire much easier in an oxygen-enriched environment. Acetylene, not stored with oxygens, must be 20 foot apart from oxygens or separated by a 5 foot tall 30-minute burn rated wall. So notice these are capped off. So technically they are quote unquote in storage. So they would either have to be separated by 20 feet or, and these are these OSHA carts they call them, separated by, this is a 5 foot tall, and that is 2 pieces of sheet metal, 30-minute burn rated wall. So these are technically by the book stored appropriately. Never use a cylinder laying on its side. The acetylene inside, the bottles inside are honeycombed. They have some acetone inside, which is a gummy liquid. And if you lay them down, it can draw that acetone up and gum up your valve and your regulator and your hoses, which is going to prevent you from being able to turn that off once you turn your valve on. So stand acetylene up for 30 minutes before using it. Oxy-fuel cutting. Your oxygen are going to have green hoses. They're right-handed threads, and typically you set that to about 20 psi, maybe 20 to 30, somewhere in there. Fuels, your hoses are going to be red, all right? So acetylene, propane, or MAP, HGX gases, those are going to go through red hoses. They are left-handed threads, so you can't mix match them. Set typically to 5, maybe 7 psi, but acetylene especially, you never go past 15. 15 psi red lines. That acetone again is going to come back up. It's going to spit out and gum up our regulators and prevent us from being able to turn that flame off. Never get oil on cylinders, regulators, connections, or hoses. Obviously, oil is flammable, and we don't want that around our oxy-fuel setup. Only light with a striker. All right, so don't want to use cigarettes, cigarette lighters, cigars, goofy stuff like that. Always use a striker, an appropriate OSHA-approved means for lighting your torch. Butane lighters, for you smokers out there that carry, plastic butane lighters in your pockets, that's pretty dangerous because any kind of little spark that maybe hits your jeans pocket and is enough to cause that plastic to melt can cause that butane lighter to explode in your pocket. So butane lighter is not cool to hang on to when you're in and around hot work. Never cut against concrete. So you wouldn't want to lay a piece down and cut directly against concrete. Concrete has a high moisture content as it's still curing out or whatnot, and it'll spall. Essentially, it'll explode. It'll start to erupt, pop loose, and again cause flying debris. So not cool. A couple more welding safety tips here. Never use welding equipment beyond its rated capacity. All right. Don't operate weld machines standing on wet or damp floors. You should always take electrodes out of their holders when not in use. Otherwise, they could arc out on grounded metal surfaces. And if you have to splice your welding cable, make sure you do it. You can't have any splices within the first 10 feet of your lead. They want that first splice away from the welder. So no splices within 10 foot of the actual welder. And that's you, not the machine. All right, so here's some review, true or false. Radiation, fumes, and toxic gases are all potential hazards related to welding. That is true. Fully charged oxygen cylinders contain 225 at 70 degrees. is false. It was 225 at 90 degrees. Number 3, in a confined space, using 100% oxygen is an acceptable ventilation source. So can we use 100% oxygen to ventilate somebody inside a confined space? False. So that would be an oxygen-rich environment. That would be a bad deal. Number 4, fuel gas fittings, like acetylene, are left-handed threads. That is true. And number 5, confined spaces are large enough for a person to enter and perform tasks. That also is true. All right, that wraps this up. Appreciate your time. Good luck on your test.